let's make a formula shift. So this is 4, 5, 6, 7. It sounds like a lot, but there are only a couple sections in each. So chapter 4 started off with the Xpbex stuff. Poor little dude. So the mean was this guy. Some of you guys still don't seem to get. When I give you probabilities, they are weights. So you can't just add up the numbers and divide by how many there are. If I got a lot more ones, that's going to pull the mean towards the ones. You can't just do that. So I guys seem to think that we can't. And then the standard deviation was this guy. Right, of course, the big mistake people make is they forget to square the mu, or you make the table wrong and you don't get the right stuff you need here. I still have people trying to plug stuff in here that should be totally beaten out of your system by now. Okay, that's not the way this works. And then it transitions into the binomial stuff towards the end of chapter 4. This guy here. That little dude. Some of you guys still trying to do homework by using the binomial PDF or CDF. And that shit ain't going to fly. You should know that. So you'll do that over again. So stop it. Or continue it if you don't want homework. And then these were the best little formulas for mean and standard deviation ever.
I just learned that today.
Uh-huh.
I just learned that today.
Oh, shit. Well, it's better than after the test. Chapter 5 was the uniform distribution stuff and just general continuous distribution stuff, right? I'm not going to make you know the mean and the standard. I know I put a problem on the practice test with the mean and standard deviation of a uniform probability distribution, but I'm not even going to put it up here. It's not going to be on the test. Do you understand?
Wait, what?
I know I put a problem, the very last problem on the practice test. Had a question about the mean and standard deviation of a uniform probability distribution, right? The one with a square root of b minus a squared over 12, remember that stuff? The standard deviation. It's not going to be on the test. So I remember last semester I had people who were like, "Can I still put it on?" Sure, what the shit, go ahead, but it's not going to be there, so why would you do that? I want you to know it exists. That's why I assign homework problems about it. I'm not going to, it's not that often used. So then we get into chapter 6, which starts off with some old stuff. And then you've also got the other way around. So that's stuff we knew from before. Let's see. And then chapter 7 is where we introduce the idea of when we have to change the standard deviation from individuals to groups. It's going to be this guy. This is not sigma over x or some weird thing. This is sigma sub x bar, meaning the standard deviation of the sample means. Little subscript. Don't freak yourself out and think it's divided by something. All right. Anything you think I forgot up here from 4, 5, 6, 7? We're going on memory, and I'm on a lot of meds right now, so you never know. I might have forgotten something. Most of them even. Well, actually, all of them even. Anything else? Anything else you forgot? That I might have forgotten? No? Okay. All right. You can add this to your past formula sheets if you want to bring them all in with you, if you really want to. That's fine. Just make sure you don't bring in anything that you lost points on before. It's kind of silly. You'll lose those points again. All right. So over to the course of today. I'll let you add something if you think we forgot something to this. You with me? Okay. Just be real careful. I mean, that first test, some of you guys hopefully learned, yes, I will take points off if you have more on your sheet than I said you could have. That only makes sense. You're cheating. So, hey, you're going to get dinged for that. All right. So now I can open it up to whatever you guys want to talk about. Homework-wise, general ideas. From the quiz? Let's see. I need myself a copy of it. Here we go. Oh, all right, so let's see. So everybody got with us? So everybody got these formulas up here written down? All right. You're talking about the one that's like probability 60 less than x less than 75 or something? Or whatever it was the Sure. There are several different versions of the quiz. I'm not going to do that one. I'm going to do... So everybody had a similar problem for 3B. They gave you a mean on a quiz. Let's say it was 75.2. Gave you a standard deviation. Let's say it was 12.1. I'm just waiting for somebody to go, no, it wasn't. It was but no. There are several different versions of the quiz. So I'm going to do a universal. It's one like this. And then I ask you, what's the probability that the grade would be between 65 and, it doesn't matter, 80. Now, I don't require you to draw a picture. But if you draw it correctly, it is very helpful. The people that don't draw pictures are the ones that make some basic mistakes because you just didn't have a visual to say, oh shit, I got to do something with this. Now, some of you guys draw the picture and then do really interesting things. Here's 75.2, and then you put 65 and 80 over there, or 65 and 80 down there. What? 65, 80. Okay. All right, at least get them on the correct side, right? And then what's the idea with this one? What's the... Yeah, well, okay. So eventually I've got to find the area between these two, but how do I do that? Yeah, first I have to make these into z-scores. So I'm able to look up areas. Now, please, dear God, some of you guys calculated the z-score and stopped. Mostly because you didn't tell yourself what you're doing. You put a formula down, didn't tell yourself it was z, and it just felt like you were done. You're like, all right, yeah, 0.12, that's like 12% to me. But it's a z-score. It's not a probability yet. Tell yourself what you're doing. Right? Stats is hard enough already. Don't make it harder on yourself by not telling yourself what you're doing. Aha, me, got you. Oh, so I got to make both of these into z-scores, look up their areas, and then subtract those. That's what makes physical sense. You never subtract two z-scores, because then you're totally somewhere else. Then you're talking about a totally different grade. So to make 80 into a z-score, I do 80 minus what? 75.2. Divided by 12.1. Whatever the heck that is. It's about 0.4. Is it? Seems right. 0.39. Is it? What is it? 0.3967. Sorry. My one skill. I got to show up on here. So.
You said the 4, right?
Say again?
0.4.
I said 0.4. That's what it is. Give me something. So that's z-score, so that's 0.4. And then 65, same way. So we're seeing how relatively far away from the mean those grades get. And that directly relates to the area below those grades. And that's why I'm able to use a z-score and get that area and subtract. What about here? I was talking too much, I forget. It's 0.8, negative point?
-0.84.
Yeah. All right. Then you look up the areas on the z-score chart. Right? What do you guys get for 0.4 area? Bless you. Huh? Oh, yeah. Yeah, for sure.
Are we going to be able to use it for the test?
Oh, shit, yeah. I had it up here a minute ago for the formula sheet.
Oh.
Yeah. Sorry, say again. So 0.4 leads you to an area of 6554. Of course, negative 0.84 gives you what area? 2005. I know the 00 kind of. All right, and then you subtract. Now, I have a special place in my heart for people that do this minus this and give me a negative answer. The answer here represents a what? Area, or even more specifically, a probability, right? Because now we know the area is the same as probability when you have a picture that's drawn correctly. You guys with me? Can the area be negative? No, I don't want to go into that room. What is that? It's a negative area. Do I get turned inside out? Is that a Hellraiser thing? We have such pleasure. No. So then you go 6554 minus 2005, and what do you get?
4549.
Yes, cool. So a little over a 45% chance to get a grade between 65 and 80 on this particular test. Or a little over 45% of the students made between a 65 and an 80 on this test. I like it. You guys, did you guys see that? Okay. So yeah, that's exactly the way that 3C is on. 3C, I think. 3B, sorry. That's how 3B works for everybody. Everybody had this problem and nobody had this problem. What? Okay.
Can we do an example of the 3A thing, please?
So 3A is the same idea, except you only have one x value to change, right? So let's say this is B. Let's say, okay, so A. So A, same setup, same idea. Now here, of course, is normal too. I didn't say that, but I said it in the problem. So now I say, what's the probability somebody gets more than 80 or something, right? So then you make that one thing into a z-score. You look up the area. Now the area is going to be on the incorrect side, so you got to do 1 minus to get in the other side. Some of you guys are doing 1 minus everywhere. It's got to make physical sense why you would do that. So when you do this problem, you make it into a z-score. You look up the area. It's going to be that area, so you got to do 1 minus to get that side. Because I'm asking for greater than.
So after we do the formula, and then we look at the z-score and then subtract 1.
Yes, do 1 minus the area.
Oh, yeah.
Yeah. So get the z-score from 80, just like we did for, right here, we already know it. I picked a beautiful number, 0.4, right? We already know it. And what was the area below 80? It was 0.6554, right? So now I got to do 1 minus 0.6554, and that'll be the answer. Because that's the other side. That's the greater than 80. Yeah. Say it one more time.
What about the number you are looking for is less than the number?
That doesn't, it doesn't change anything, to be honest. It's still, so if I would have said, if my part A would have been probability x greater than 65, right? Then you still get a z-score for that. We got a z-score for it, negative 0.84. You look up the area. Okay, look up the area. We got 0.2005. And you do 1 minus that to get the other side because I want greater than. I mean, you guys are trying to make too many cases in your head. Well, if this, then this. If this, then this. If this. No. If I want greater than, the chart always tells me less than. It doesn't matter where the thing is. I look it up, do 1 minus to get the other side. Done. So the idea here is if I know one probability, the opposite of that is 1 minus that.
Then I got another question for 1C. I know
Oh, yeah.
like what to do if it was like equal to 4, but in this one it says greater than 4.
All right. Does everybody got what they want from here? So if I have uniform of course looks like this. A lot of you guys were drawing normal distributions, but uniform means uniformly distributed means it's the same for everybody. That's why the word uniform, you wear the same uniform. So if this was like 11 to 38, what would the height be? Yeah, 1 over 27 to make the area 1. I like it. Now, if I asked you the probability, some of you guys had a question like this. Equal 16, not between two things. None of that stuff, right? Equal 16. Well, how wide is that? How wide is that? 0. So it's a 0. So any equals question, I'm hoping I didn't confuse you. I'm hoping I got some of you guys interested in the idea of iota when I talked a little bit about that. But basically, the answer is 0. For the produce is 0. The one you're asking about now, what if I said what's probably x is less than 40? That is not a problem. How many of the possible things occur below 40? How many of the possible numbers occur below 40? What are the possible numbers? 11 to 38. So how many of them occur below 40? All of them. So what's the probability I get something below 40? 100%. If I said x greater than 10, same idea. Right? If I said you roll a normal die, what's the probability you get more than 0? Like 100%. They're all more than 0. What are you talking about? Same idea. They're all more than 10. They're all less than 40. It's 100%. Now, if I would have said probability x less than 10, what would that be? There's nothing out there. 0. Okay. Okay, cool. So what do you want to look at now? You look at practice test, homework questions. We can go back over how to do something.
Number 5 on practice test.
Okay.
I know how to get that.
So what kind of problem is number 5 on the practice test? What kind of problem is that? Is that a z-score kind of problem? Is that a xp of x kind of problem? What? Oh, okay. Give me some more. It's not an xp of x. Number 5. What kind of problem is number 5? 88% think that DNA tests are reliable. We select 24 adults. 24 sounds like it's going to be what letter? N? The 88% NPQ. It's an NPQ problem. Binomial problem, right? You should be able to identify those pretty easily. There's a percentage chance of something, which means there's a percentage chance of not that thing. And then they take a certain number, N, P, Q, all this stuff are kind of jumping out at you. That's an NPQ problem. So part A is going to be that probability formula for that. So identify for yourself what's going on. So what N was 24. Got 24 total people I'm looking at. P is 0.88. I like it. Q would have to be what then? 0.12, the rest, so that they fill each other in, make 100%.
So to get Q, you gotta do 100 minus... No,
1 minus
1
P.
minus 100. 1 minus P.
Yep.
Okay.
Because what's true about P plus Q? 1. So subtract P from both sides. Q equals 1 minus P. It's crazy. Algebra, save the day. Sorry. Just hate all this shitting on algebra happening. And algebra is one of the most basic things you want to know for anything. All right. Enough of that. So you always do, if you know P, you know Q is 1 minus that. Okay. And so for part A, what's X?
22.
Yeah, 122, exactly. So the probability of 22 will be 22 together. 24, choose 22. Right? N, choose X. P to the X. Q to the N minus X. Right? That guy. So whenever I have an NPQ problem, a binomial problem, I'm saying, what's the probability exactly this? You're going to use this formula for sure. 0.88 to the 22nd, 0.12 to the second. Because these two have to add up to be the total. Which makes sense.
So on the calculator, that's how we're going to put it.
Yep. I like it. Now, if you know the binomial PDF and CDF shit, I don't know. I mean, as long as you set this up correctly. What I love is when people set this up wrong and the right answer shows up. That's awesome. I love that shit. But as long as you get this set up correctly in the paper, I don't have a clue where the answer came from. But as long as this is set up right, that's your work. So if you forgot to put this in there,
Is it n times x?
say again?
No minus.
N minus X, yeah. So the rest. If this is X, what's left for the other guy? The total minus X. Yeah. Now part B, this is part A. Right, so you just put all this in the calculator, bam, bam, bam. Part B says the probability of X is less than 22, right?
Yes.
Yeah, shit. What's wrong with doing that directly? Less than 22 would be what? Not 22, like 21, 20,
19.
19, 18. You have to do this formula for each of those, right? If you wanted to be that silly. What's better is to do the opposite. What's the opposite of less than 22? I love you guys. What are you saying? Yes, greater than equal to. So 22, 23, or 24. What's awesome about this is we've already done 22 for part A. So now you just do that formula for 23, do that formula for 24, and then subtract all of those from 1.
Wait, what?
I love you guys. All right. Your what came after I said this, so I'm assuming that you're okay with what I wrote down here.
Yes.
Okay, no, all right. So your what should have come earlier. Probabilities, opposite probabilities are always 1 minus the other one.
Yeah.
Okay, so what's the opposite of less than 22? Equal or more than 22. There you go. So 1 minus that is this. And why is this better? There's only 2 things they got to do because I already did one of them. Here, there's 21, 20, 19, 18, 17, and all the way down to screw that. So whenever there's less work for the opposite situation, yes, I will do that, right? So if you figure out 22, which you did up here, do 23, put a 23 in here, 23, 23, 1, put a 24, 24, 0. Figure out what those are, and then take those away from 1, you're done. I know you guys seem to believe that's magic, but that's bullshit. It's not magic. What can happen? 0, 1, 2, 3, up to 20, 21, 22, 23, 24, right? Right? Those are all the possible values of X. What do all these have to add up to be? 1, whatever the hell they are. So 1 minus these has to be, or 1 minus these has to be these. That's all we're doing. 1 minus these has to be these. Nothing amazing. So, since the probability is 0 plus probability of 1 plus probability of 22, 23, 24 equals 1, then 1 minus these must equal these. That's it. That's it. That's all I'm going to say. That's all there is to it. Not magic.
What if it says find the probability that none of those things?
Oh, well then I just have to put a 0 in. That's done. There's only one way to have none.
0 where the 22 is at, right?
Yeah, because we want successes to be 0 then. Yeah. If I said that. On this problem I wouldn't, because that would be really, 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 really small. Probability. Stupid small. All right. Yes, I will. I'm just not going to do it yet. It's one of my little tricks to try to make you guys do what's right for yourselves. Yeah.
What about number
1D. So once you know what the mean is and what the standard deviation is, that's that same thing we keep doing about put the mean in the middle. So think on this one. The mean you get should be 5.91. And the standard deviation you get should be 3.316. So this is 1D. If they go up and down one standard deviation from the mean, I add 3.316 and end up basically at 9.2 something. I subtract 3.316. And I end up at 2.6, roughly 2.5, something below.
Is it in 2 places?
No, this is within one standard deviation. Yeah. So which data points are caught in here? Which data points did I catch in there? Look at your list of data. Those are the X's. 5 and 6. I caught 5s, all the 5s, and I caught all the 6s. Right? So it's not 2 out of 5. That doesn't make any sense. If I catch all the 5s, what percentage of the data did I already catch? Huh? If I catch all the 5s, what percentage of the data did I catch? 0.352. What percentage of the data is 5? 0.352. Because what's the big P mean? It means probability or percentage.
Oh.
Same thing. So I'm asking you, what percentage of the data did you catch? Well, I caught all the 5s, so that's 0.352 already. And I caught all the 6s. So that's an additional 0.154. Add those up. What's up? All right.
Oh, that's why I didn't do it right.
Now, if I said I caught the 1s and the 2s from this list, right? Would that be 2 numbers out of 5? Numbers 2 out of 5, 40%. Why does that make no sense? If I caught all the 1s, that's 3 numbers right there. Okay, now what in that list tells me how often that number shows up? The P of X. That's the percentage of the time that number showed up. 35% of the time, the number was a 5. So if I catch all the 5s, that's 35% of the information. So you don't say 2, 5, 6, 11, 12. You don't say, I caught 2 numbers out of 5 numbers. That makes no sense because there's not equal numbers of 2s and 5s and 6s. Right? How much? If I said all the freshmen and all the juniors at a high school want the lunch changed, is that half the school? Is that half the school? You don't know. Why don't you know? Because I don't know how many freshmen, juniors, sophomores, seniors there are. So if I catch a category, I've got to know how many is in that category. So I caught all the 5s. There's a lot more 5s than there are 6s. There's a lot more 5s than there are other things. I've got to take that into account. I caught that percentage of the data, plus that's for the 6s, and then it's going to tell me the total percentage that I caught. So here, if I count the 1s and the 2s, what percentage is the 1s? That'll be 3 out of 3, 4, 5, 6, 7. 3 out of 7. Plus all the 2s, 1 out of 7. Well, that's 4 out of 7. That's not 2 numbers out of 5 numbers. Because this was pretty heavily weighted. When I caught the 1s, I caught a lot of stuff. All right.
So do you go 1 or 2 times, or it doesn't matter?
The problem says 1.
Oh,
Yeah, so you only go once. Yeah. All right, let me ask you this. So let's just say this is, I asked people to give me a random number, and this is the results, right? For number 1, what percentage of the people said 2? 25.1%. I love it. Now, if I put all the people that said 2 and 3, if I put them all in a room, they said 2 or 3, I put them all in a room, what percentage of everybody did I just put in that room? Put everybody who said 2, everybody who said 3 in that room next door. What percentage of the people did I just put in that room? Yeah, 60.3. You add them up. Of course you do. 25.1% of them said 2. 35.2% of them said 5. I'm sorry, I said 3 didn't. 5. You put them next door, that's going to be 60%. All right, I'm sorry. It was 5. Okay, just go with me. Do you guys see what I'm saying, though? Those percentages are the percentage of times that data point happened. So if I catch all the 5s and I catch all the 6s, I have to add the percentages together to get the total percentage of what I just caught. Saying 2 out of 5 is not fair because these are differently weighted. They're not all equal. Half the data is right here. Because 5 is pretty heavily weighted. 35% are 5s. Okay, that's all I'm going to say about that. Okay. Where else do we want to look here? Remember, number 4 is that one that deals with the changing the standard deviation.
number
4B. Oh, yeah, okay. Did you do 4A, number 1? Yes. Do you notice how 4A, number 1, has an answer that seems like it's related to 4B? Because the question on 4A, number 1, is probability that X is greater than 302. Which means, another way to interpret probability is the percentage of whatever greater than 302 is this. All right, so for 4, let's see. So the percentage of students who made more than a 302, for part A, that's what you calculate, A1. Whew. And for that, you should get, did anybody do that one?
For 1?
Yes.
Yeah.
What'd you get? Looks like you got the right answer.
Yeah, 27.2743.
All right, so that's what you get for 4A1. So the percentage of students who scored more than 302 is 27.43%. Now, if I tell you, okay, there's 2,000 total students, how many do you expect to have made more than a 302? How do you figure that out? No. If 11% of everybody is left-handed, and there are 40 people in this room, how many people in this room do I expect to be left-handed? 11% of 40. If 27.43% of students scored higher than a 302, how many out of 2,000 do I expect to make higher than a 302? 27.43% of 2,000. You multiply. 2,000 times 0.2743. And again, it's. I like this question because it takes this answer you get and it does more with it. Just forcing you to realize what the shit this means when you get it. It is a probability, but more importantly is a percentage of that group that does this. And then I can use it any way I normally would use that kind of thing. So I can use it here. Okay. Now, I agree, it's a different kind of question, but that's the way you can look at this. That's a percentage answer, and then I give you a number, you can just take the percentage of the number. Yeah. So, which one, sorry?
Number
3?
three.
Oh, yeah. All right. So 3 is kind of getting us ready for something coming up. At the same time, it is not a trick question or some kind of hard question. It's not hard at all. But it is getting us ready for like the next section, the next chapter. 3A is old news. I want to find the z-score that's got 91% below it, so it's got to be here. You just jump to the chase. Easier guy, make that make sense, right? Half below would be here, 90% would be up here somewhere. So how do I find that? Well, what do I normally do? And this is a normal distribution. That's why I can draw this. Normally, I have a z-score and I find this. Well, now, we've done this before. You just do that backwards. Yeah, get as close as you can to 0.91 in the body and look out to see what z-score that would be. Right? If I can look out here and go in, I can look in here and go out. It's the beauty of math, is you should be able to go both ways. So, you look up that z-score for that. And then part B is the more interesting part. This is the one that seems like it's brand new, but it isn't. Middle 91%. Now, why is the chart going to freak out about that area? If I try to look at 0.91, why does that have nothing to do with the answer to this question? The only area the chart understands is the area below a z-score. Now, where are my two z-scores I'm trying to find? Where are they? One is here and one is there. And if the chart only understands areas below a z-score that I want, that seems to be a good candidate. What's this area right here? If there's 91% inside, there must be 9% outside, which means there must be 4.5% on that side. So 0.045. Not a damn thing amazing about that. 91% in, 9% out. Why can't I just cut it in half? Because the normal distribution is symmetric. Boogie, woogie, woogie. Now what the shit was all this about? Well, again, I want that z-score. I want that z-score. What's the only thing the chart understands? Areas below a z-score. Now I know the area below one of the z-scores I want. Now if that was -2, that would have to be
Positive.
Because it's symmetric. Holy shit. That's why I only have to worry about getting one of them. The other one's going to be the same number, strip the negative off, because it's symmetric. So what do you get? So again, these are both just looking up those numbers and getting as close as you can.
Are you doing -2.61?
No. I think you looked at point, I don't know what you looked at.
So it's negative 1.70.
Yeah, point, I think you looked at point 0045 maybe. So the closest you can get to .045 is .0446. So if you want to, try to look that up, see what you get, and let's see if it's right.
Negative 1.70. Or positive 1.70.
You get negative 1.70 and positive 1.70. And up here, anybody do this one yet? I mean, this one's a little bit easier.
1.34.
Yeah, 1.34. I think it's .9099. The closest you get to that is .9099, and the closest you get to this is .0446. Just get as close as you can. Again, if you had one of these new school teachers that let you use technology, you get the answer exactly right, but then you don't learn shit. So I like to go back the other way, learn shit. Yes?
How do you get the numbers on the two?
Say again?
On the ends, the .045?
Oh, again, if there's 91% inside, how much is outside? 91% inside, 9% outside. How much on this side? 4.5%. Then I get as close as I can to that, which is this in the chart, and I look out and I see negative 1.70. Yep. Can you guys find .0446 in the body of the chart if you're having trouble with this? Obviously, dear God, obviously this is going to be a negative z-score because it's down here. .0446, that's as close as I can get to .045, and that is negative 1.70. That's where that came from, negative 1.70. If I know a z-score, I can look up the area below it. If I know the area below it, I can look up a z-score. It's got to work both ways.
Was there a correction sheet for the practice test?
You mean an answer key?
Yeah.
Yep, there is. Can I get it? Not yet. Haha. Now you can just say, you don't have to have a specific question. You can have a specific homework question or a question from the practice test. You can have a general, how the shit does this kind of problem work?
So you said on the test we're not going to have the uniform probability.
No, we will have uniform probability distribution problems. I will not ask you for the mean and the standard deviation of it.
Okay.
Yes. We'll have problems like the one I gave you on the quiz.
Okay.
Yeah.
Can you reiterate that?
Sure. We'll have problems for uniform probability distributions just like the one I gave on the quiz. So they will not involve finding the mean or the standard deviation of a uniform probability distribution. I know I'm going to have something. You said we weren't going to find any means. Oh, God. Uniform probability distributions.
So find the mean and the maximum values.
Yes.
Do you have to do like twice, or
Yes.
does it matter?
Totally matters. So right now we're defining unusual to start 2 standard deviations away, which if you think about it just makes sense. The standard deviation is how far on average all the data points get from the mean. So if I go out 2 steps, it should be unusual for a data point to be more than that away. So that's why we define it right now. Now, why do I keep saying right now? Because when we get to chapter 9 and 10, we're going to start being more specific with what we call unusual. Certain situations I want to call unusual much closer. So my go-to example is if I'm in a nuclear reactor, how unusual do I want to let the activity get before I get off my ass and go check on things? Probably not very far away from usual. I mean, so I'm going to define it to be a lot, maybe 1.2 standard deviations away, or 1 even, I don't know. When it starts to go towards the yellow, I'm like, it's still green, but it's going towards yellow. I'm getting off my ass and going to check what the hell's going on. You guys semi with me? I don't want all Godzilla movie happening again. Yes. Oh. 6B and C? So, first off, 6A is needed to set up the idea for the rest. How tall is that going to be? So now, for subscale problems, you could just use that same picture. So now I want 4.4 to 4.7. So probably is going to be the area of that. So then it's just really, can you find the area of that rectangle is the question now. Well, how wide is it? 0.3. And how tall is it?
1/6.
So that's the probability between 4.4 and 7. 4.7. Probability 4.4 to 4.7. And whatever the shit that is, right? 3/6 is 0.5, so 0.3/6 is 0.05. Or just plug in your calculator. Right, so that kind of a uniform probability question has got to be meat and potatoes. I mean, it's got to be like, feed me more of that shit, Jeff, because that's just how wide is the damn thing and how tall is it. It's just areas of rectangles, which is almost too nice to believe. But that's what leads us to the normal distribution. That's why we have a chart with all the answers on it, because it is just related to the area. We just needed somebody to help us get all the areas, and we got all the answers. The part C is the same kind of problem we saw earlier. X equals 5. What's probably X equal anything? 0. Because there's an infinite number of things that could happen. Because it's continuous.
So with the Ex P of X, when you get to the X squared P of X, what was the shortcut you used? Instead of doing X squared
Oh.
X and then going in.
So this is L1, this is L2.
Yeah.
This will be L1 times L2, and this will be L1 times L3. X times XP of X is X squared P of X.
Okay.
Yeah. Now, this showing up on your formula sheet means a lot of points off. It's not a show me how to do problem sheet, right? If you had teachers in the past that did this for you, they are not good teachers. If you disagree with me, too damn bad. You're wrong. You don't learn shit if you write for yourself how to do something. You gotta know how to set this up, because that forces you to try to realize what the idea is. So I'm always trying to trick you into doing. Can you get to what the idea is? Yeah.
So for the last column, it would be the first two multiplied with each other?
No. The first two would just be this.
Okay.
This one needs X squared P of X. So I just do L1 times L3,
Okay.
because that would be x squared p of x. Yeah. The big mistake people make is they just square this, but why is that wrong? Because then that would be x squared p squared. Shit. So again, algebra either saves you or kicks you in the ass if you don't know it. X times x p of x is x squared p of x. If you know algebra, you'll do the right columns. Yeah.
What about standardization of the expression?
Say again.
Standardization
Standard deviation of.
and between numbers.
Oh, back to number 6. Okay. So again, this is the problem I put on the practice test, and I'm not going to have it on the actual test. Yeah, so I'm not even going to worry about it right now. I wanted to put 6D and 6E on here because 6D, you calculate the standard deviation. 6E, you divide that by the square root of 43 because that's what you do when you take samples and ask about sample means. Yeah. So real quick, I think there were a couple times in the homework you had to do that same thing. 6D, the mean would be 2 plus 8 divided by 2, so 5. Standard deviation would be the square root of 8 minus 2 squared divided by 12, which would come out to be 1.732. So in part E, I take a sample of 43 and I ask a question about the sample mean. So what's got to change? Standard deviation's got to change. This is the one that's good for individuals. I need to change it to become the one that's good for groups. So my only purpose there was to show you it doesn't matter where this comes from. If I take samples and ask questions about the sample mean, that has got to change. That was my only purpose for putting that down there. I think there was at least one homework problem that